Alright guys, here we go. This is the last video for 2.6, and to me this is actually the most important type of question to know how to do. It boils down to finding all zeros of a polynomial function. We've kind of done this something similar before, but along the way we're also going to check for rational zeros that are possible and the number of positive and negative zeros that are possible. Okay, starting with number 8. Let's check sign changes first, part A. So looking at here, starting off positive to negative, that's 1 sign change. Back to positive, that's 2 sign changes. Back to negative, that's 3 sign changes. Which means, according to positive sign changes, there's 3 or 1 positive roots. Right? And what about this? I'm going to check f of negative x. Going to give me... Okay, I'm going to run out of space there. I'm always telling people not to write so close to the edge, and I should follow my own advice. That's negative x cubed minus 9x squared minus 25x minus 17. So actually 0 sign changes, right? Which means 0 negative roots. Okay, that's good to know. That means let's go to part B now. What are the possible rational roots? So P should divide 17, Q should divide 1. That means possible rational roots are going to be plus or minus 1 and plus or minus 17. Now, I'm going to just hope that's 1. I know it's not going to be negative 1 because there's no negative roots. So check for 1. The coefficients were 1, negative 9, 25, and negative 17. And look, by inspection, it looks like that is going to work. Watch. 1 comes down. 1 times 1 is 1. Negative 9 plus 1 is negative 8. Times 1 is negative 8. Plus 25 is positive 17. Times 1 is 17. And those add to 0. So perfect. So this means that x squared minus 8x plus 17 would be the result if I was to divide by x minus 1. So, you know, when you're doing these kind of things, trying to find all zeros, you're just trying to get down to the quadratic form. Once you're in quadratic form, if it factors, perfect. But if it doesn't, like in this case, it does not, then just plug that thing into the good old quadratic equation. So that means x is going to be negative b, which is 8, plus or minus the square root of b squared, 64, minus 4a, which is 1, c, which is 17. 17 times 4 is 68, divided by 2a, which is 2 times 1. That's 8 plus or minus the square root of negative 4 over 2, which is 8 plus or minus 2 square root of negative 1 over 2, which is 4. Plus or minus I. So there it is. There it is. I found all my zeros. My zeros, let's write that in red. My zeros are, first of all, 1. I don't know why I wrote a parentheses. 1, 4 plus I, and then 4 minus I. Those are all the zeros. So I ended up with one positive root, not 3. The other ones are imaginary. Okay, that's number 8. Number 8's done. I don't know why I chose to cross that out with a highlighter. Let's cross that out with the pen instead. And let's try to erase a bunch of this stuff at once. Get the stragglers with the eraser. This takes so long. Okay, number 9. Number 9. Okay, so first, gonna start with a and check how many possible roots there are. Right? Let's count sign changes. Positive to negative, that's 1. Negative to positive, that's 2. So 2 or 0 positive roots. Now let's check f of negative x. What is that? That would be negative x cubed minus 5x squared minus 7x plus 13. So I got 1 sign change from negative to positive right there, yeah? So that means 1 negative root. Okay, that's good to know. I know there has to be 1 negative root. So I'm going to check for that negative root because I'm guaranteed at least 1 negative one. And doing part B, P has to divide 13, Q has to divide 1. That means plus or minus 1, plus or minus 13 are the only possible rational roots. Yeah, these are possible rational roots. So I'm going to hope that -1 is one of them, because that would make my life easier. Otherwise, I check -13 and hope that it's, usually there's at least something that's rational. Not always. But, for the kind of questions that we're given anyway. Okay, my coefficients are 1, -5, +7, and +13. Run the algorithm, pull the 1 down. 1 times -1 is -1. That's -6. Times with +6, 6 plus 7 is 13. Times -1, -13. And that's 0, perfect. Perfect. So -1 was one of the roots, and the resulting quadratic is 1x squared, or x squared, minus 6x plus 13. Okay, looking at 13, does that factor nicely? No, because 13 is only the product of 1 and 13, and those do not subtract to 6 anyway nicely. So just plug the result into the quadratic equation. 6 plus or minus the square root of b squared minus 4ac, which is 4 times 13, all over 2a, which is 2. That's 6 plus or minus the square root of 4 times 13 is 52. 652 minus 636 is 18. All right. Oh, 16. I'm sorry. So bad at arithmetic. I should have taken Kumon. So sad as a math teacher. Okay, over 2. Okay, that's nice though, because 16 -16, yeah, is a nicely square rootable number. It's 6 plus or minus 4i over 2. And both of those are divisible by 2, so I get 3 plus or minus 2i. Nice. Which leads us to our zeros. There's zeros. R, first of all, -1. And then 3 plus 2i, 3 minus 2i. There it is. Okay, that's that. Okay. So that was number 9. I got 4 more to go. 4 more to go. Yeah, it looks like this might be a little bit of a longer video here. But, what are you going to do? You notice this process that I'm running is kind of similar to something we've seen in the past, right? It's kind of very similar. Only difference is now some of the times we're getting complex roots, but I feel like, did we have that happen? I forget if that happened before. But the process anyway is the same, right? You're doing synthetic division. We have a couple extra tools now, checking the number of possible positive and negative roots. So let's check the number of sign changes. That's and then we'll check. So positive sign changes. Here's positive to negative, that's 1. Negative positive, that's 2. Positive to negative, that's 3. So 3 or 1 positive roots. Okay, what about the negative one? So if I do f of negative x, that's going to be negative 3x cubed minus x squared minus 12x minus 4. So the signs are all same. That means there's 0 negative roots. Okay, which saves me looking for negative roots, right? I'm going to go straight to looking for positive roots. Now what are the possible rational roots? Well, p should divide 4, q should divide 3. So I've got 1, 2, or 4 as possible roots, plus or minus. Actually, I know they're not negative. So I'm going to go straight to only the positives. 1, 2, or 4. Also 1/3, 2/3, and 4/3. But, I hope that it's going to be the whole numbers. So let's check the whole numbers first. Let me just do some mental math and plug in 1. If I plug in 1, it's going to be 3 minus 1 minus 4 plus 12. That's not going to be 0. So let's skip 1. Let's check 2. 3 minus 1, 12 minus 4. 3 comes down. Times 2 is 6. Adds to 5. 5 times 2 is 10. That's 24. I mean 22. Times 2 is 44. So way off. Okay, not down. Okay. Oh. Actually, guys, look what happened. Look what happened. You see how these are all positive numbers? So we should keep in mind actually our other theorem, which says that if you divide by a positive c, you do synthetic with a positive c, and you have all non-negative values in the bottom, that's an upper bound. So 2 is an upper bound, which means you can't have it being 4, nothing above 2. Actually, that's the only thing above 2. But it does tell me it's not 4, which means I've got to go to these fractions then to find my other one. Let's start with 1/3. Okay, what is it? 3, -1, 12, -4. 3 comes down, times 1/3 is +1. Yeah, +1 plus 1 is 0. I see. Times 1/3 is 0, right? Plus 12 is 12, and 12 times 1/3 is 4. 4 plus -4 is 0. So, hey, beautiful. And check this out. That's 3x squared plus 12. That's wonderful news. Because why? Because that means our last two roots are going to be really easy to find. Here's what happens. So let's try to write this in factor form, right? This is x. First root was 1/3. Then I've got 3x squared plus 12, but I can simplify that. I can factor out a 3. That's going to be x minus 1/3. Pull out that 3. This is x squared plus 4. So that means 2i and -2i. Those are my missing roots here, right? Because x plus 2i times x minus 2i is equal to x squared plus 4, right? If you don't believe me, then just multiply it out. Okay, so that means my zeros. Okay, let's say you didn't see that. You didn't see this whole thing that I just showed you. That's okay. You can always just resort to plugging this thing and punching that thing into the quadratic function, and you're going to end up with the same result that I just got. Okay, so if you want to just do it mechanically, that's fine. But anyways, the zeros are going to be, I took a little shortcut, 1/3, 2i, and -2i. Great. 3 down. Halfway there. See if we can lasso the rest. Nice. Okay, number 11. Okay, now we have slightly higher degrees. Fourth, we got 2 4 degrees and 1 5th degree. Let's check our niche first. So here, positive to negative, that's 1. Negative to positive, that's 2. Positive to negative, that's 3. So 3 or 1 positive root. Okay, what about f of -x? That's going to be x to the 4th plus 4x to the 3rd minus 5x squared minus 38x minus 30. So I go positive to negative here, and that's only changed. So I got 1 negative root. Okay, I know I have at least 1 positive root. So that's good to know. And then let's look at what are the possible rational roots now. Okay, there's possible rational roots. So P should divide 30. Q should divide 1. So possible rational roots are going to be plus or minus 1, plus or minus 2. All are just basically the factors of 30. Plus or minus 3, plus or minus 10, plus or minus 15, and plus or minus 30. Let's check 1 first. And our coefficients are 1, -4, -5. Along the way, if we happen to see an upper bound, we're going to keep that in mind because that will make our work a little simpler. 1 comes down. 1 times 1 is 1. -4 plus 1, -3. That's going to be -3, -8, which is -8, which is 30. Oh. First chance, first try, beautiful. Okay, so 1 was a root, okay? That gives me with x to the 3rd minus 3x squared minus 8x plus 30. Okay, so I still have the same options as before for my possible roots because I still got the 30 as the last term, 1 is the first coefficient. Okay, now 1 is not an upper bound. Let's count sign changes again from here. So we got one sign change there, 2 sign changes there. Okay, it doesn't actually tell me anything new because I know there's 1 or 2 positive roots looking at that. And I'm going to get 1 negative root. I'm guessing the other way. Yeah. Okay, so let's see. What should we do? We have to whittle this down to a quadratic, right? So we got to find one more at least. Let me just by inspection look if 1 would work. 1 does not look like it would work this time. So let's try 2. No, let's look for a negative 1 because I know there's at least 1 negative 1, right? So let's try negative 1. Negative 1. By inspection doesn't look like it's gonna work. Let's try negative 2. And I'm using this result there this time. So 1, negative 3, negative 8, positive 30. 1 comes down. Times negative 2, negative 2. That's negative 5. Times 2 is positive 10. That's going to be 2. 2 times negative 2 is negative 4. And that's going to be 26. Okay. So I'm not alternating signs, which means it's not a lower bound. I can go lower. Let's try negative 3. Using the same coefficients. 1, negative 3, negative 8, and 30. Negative 3, that's going to be negative 6. Times 3 is going to be 18. Oh, looks like I found it, guys. Which is 10 times negative 3, negative 30, which is 0. Perfect. So I got x squared minus 6x plus 10. I swear I've seen this quadratic before. X squared minus 6x plus 10. Where did I see that? Oh, I erased it. I think it was when I had 3 minus I, though. Yeah, it was 3 minus I. Okay, anyways. That means I found the important pieces that I wanted. I'm just trying to think about time here, guys. I feel like this is going to be long if I do all 6 questions here. And I don't want to go too far over 75 minutes either, so I might cancel a question or at least separate it. Yeah, maybe it'll cancel one. Anyway, let's finish this question first. So far I found 1 and negative 2. Oh, no. Sorry. 1 and negative 3 as the roots, right? The last one, to find the last 2, I'm going to just take that quadratic. X squared minus 6x plus 10 and punch it into the quadratic equation. Negative b, which is positive 6, plus or minus square root of b squared minus 4ac, which is 40 all over 2. Oh, yeah. See, this is one we saw before. 6 plus or minus square root of negative 4 over 2, which is 6 plus or minus 2i over 2, which is 3 plus or minus I. Yeah, see, we saw that guy. Remember? Back over here. Back in question number 5. I knew I recognized that quadratic. So 3 plus or minus I. Okay, so that means putting all our zeros together, we've got 1, negative 3, 3 plus I, and 3 minus I. That is what I had. Yeah, 3 plus or minus I. So there you go. That's the answer. That's the final answer. All right. I think what I'll do, guys, is I'll just stop this video here before it gets any longer. And then I guess we'll have a 5th video for the last 2.